Hello everyone again. Welcome to I think 15th live stream. Yeah, this passes super fast. I hope you're enjoying the weekend. This time, an idea is to cover stuff I mentioned last time, and that's the project structure. So I've managed to set up I think the right project structure for Memgraph Mage Rust modules, and also cover issues with the testing. I actually resolved I think I resolved the issues. I did quite significant amount of work regarding the unit testing by using mockall library, and I'll just go through that. As usual, if you like the content, please hit the subscribe, like, or share buttons. Uh, and that's it. Let's get started with the explanations. I'll jump into my. Let me just check the YouTube view. Yeah, it's good. Yeah, if you have any comments or questions, as usual, just ask. And I'm discovering a bunch of stuff, and also the mage Rust infrastructure is quite complex in terms of like interactions between Rust and C. So for a lot of these things, I'm not 100% sure. I'm trying to get all these things right. So if you have any suggestions, feel free to jump in. All right, I'll now switch to my code view. Here we have a couple of things. Basically, since the last time, I've figured out how the code will be unit tested. So we'll be use the mockall library. Maybe I can expand this here just to show what that is. So basically, that's a very good Rust library with a lot of testing functionalities. And also, I found this let's say issue on mockall library that explains similar problem that we have. So basically, the biggest problem is that we have a C code that has a bunch of structs and functions which have to be called during testing, but we also have additional problem that we actually don't have the implementation of the runtime. So some of these implementations are inside Memgraph binary, and they are hidden to us. So in order to test properly, we need to mock that all, and that's linked here. But I'll go through the code I did and explain that. In addition, also I was not sure about the project structure, and apparently Rust creates a support usually like one executable or one library, one static or dynamic lib per crate, or no binary at all. You can just have standalone code that can be used and compiled, but there is no great support for multiple libraries, let's say, per crate. And that's also, if I understood correctly, that's also kind of design decision. So these crates should be as small as possible, containing only one thing inside. An option that I saw is are called Rust workspaces, and that's basically a set of. I mean, you can change the cargo toml file on a top level and add these workspaces. So basically, each folder in the project will contain a separate cargo file, and then like the whole project structure, But I tried to set up that, but at the end of the day, I had like some issues with that. I couldn't figure out the right setup. And it's basically the whole thing is very simple to having a separated, let's say, completely separated Rust projects on a top level, because you still need the toml file, and you still need the source folder and all these things. And then I decided to use then I decided to completely separate these things. So I've created the rsmgp system crate, and that will contain the library code and the Rust bindings. And then for each additional module, we'll just create completely separate Rust project that will depend on this crate to find the bindings and to call these system level dependencies. And why is that so? And that's also aligned with the existing CPP structure. In the CPP, we also have a folder for each query module, and it has its own, let's say, CMake file with all stuff included there. I mean, it's not that isolated, but it's very similar. So I think that makes sense to have here as well. And also, I've added the CI workflow, so we can just go and I can just check out here and showcase a bit more about these things. So okay, let's do first the testing. So in order to use mockall, you need to include the mockall library, but also mockdouble. Mockdouble is very interesting because it's very simple. So is that mockall double? Yes. Yeah, so it's a very simple crate that has that macro defined mockall double, and basically what it does, it's just so whenever you put this attribute here, hashtag double under that's under this namespace, that will generate this code. So in not testing environment, while the configuration is not testing configuration, the code will use foo namespace. But if the configuration is testing, then it will use foo mock foo as foo. So just the mocked version will be used, and this is very nice here because it's all compile time and all optimized. So you don't suffer any. There is not any runtime overhead here, because in the runtime the code will use original function. Okay, let's go back here. We also had to, because of mockall, we also had to change a couple of things in our build rs file. I've linked the original issue where there is the whole explanation why we have to do that. But basically, we had to separate. We have to generate, since we are mostly trying to test. I mean, we are trying to test only these functions in the MG from the C part of the query modules. We don't need to generate these mockall. I didn't explain that. So in order to make in order to generate these mocks, mockall provides mockall macro, I think, or that's attribute. I think that's attribute, and you just put an attribute mock call on a structure or on a function, and Rust will, like the mock call, will automatically generate the mock code. And basically the idea here is to just generate the entire all the mocks for all the functions from the cQuery modules API. We don't need structs at this point. Maybe I will need some of these things to accelerate something, but we'll see about that in the future. But in this binding config, I just blacklisted all functions first, and then these structs are generated. So here all bindings for the structures are generated, and then here we blacklist all types, and then we generate all the functions, all the bindings for all the functions, and then we also create these mock call. We add these mock call attributes. That's it on that side. And then okay, slightly change here. Also, so instead of referencing directly bindings, I mean that was here in before. I'm not sure when I changed that, but anyway, we just include whatever is generated in the bindings rs file. The whole file is just included inside this MGP file, and that's a module. So the whole file, all these bindings are now making the MGP module. And then we have the actual rs MGP module. In this file, we have all the library code in Rust. We just import all MGP bindings, and we also generate these mock stuff here. While I was doing this, I also figured out a bug. Obviously here, I mean a bug. It's not a bug, but in the testing code, I've never set the value in the MGP value struct. And here, prior to make the free call, I didn't check for is null. That's like a classic error. And here, I just check before calling free. I just check is that null. If it's null, then it doesn't make to destroy it. Doesn't make sense. Actually, it's gonna crash everything. So it's not wise at all. And then, okay, I had to introduce that FFI namespace because of the mock call stuff. But that's just a change in the namespace. That's nothing huge. That's all the same. Just adding here, and then this now here is super interesting. So this is the first simple test I did, and it's nice here because for each function we have in the bindings file, the mock all library provides MGP value context. I mean, it provides the context function, and then when you have that context, you can define how that function should behave. So the MGP value make in this test should be called once, and it should return the thing defined here. So it should be defined here. I just check that it should be called by passing zero value, and it is returning null pointer for now. And also we have in that the same call, so MGP value make it, so we have the function that we want to test, make int value. That's the Rust library function, And in that function, we call mgp value int, make int, and also mgp result set error in case of if allocation fails. And we also expect that to be called once. And also here we just print the error, but later in the future I will make the actual check here. And then we actually call make integer value and pass it 0 as a value, and the rest are mgp result and mgp memory pointers. But for these tests, these are just null. I'm actually not sure how I'm going to test that in the future, because I cannot create these objects easily, because I don't have the size of them, and the layout is not available. But I assume if I will really need to create these objects, I will try to make changes to the mocall configuration in the build rs file. Okay, I hope this is clear. I mean, it has a bunch of small details, but that's high level overview. That's about mock all. Let's go back just to the project stuff. Yeah, maybe I can jump to the code quickly, because I actually never run the test from any tests from Cargo project. So here I have the project code in the project code is here under rsmgp system, and the tests are located here. So at the end of this file, at this point, if I jump here, I'm now under this directory, made rust rsmgp system, and if I do cargo test here, it will say that simple test is okay. And when I'll add the actual code in the future, it will be much simpler to do the actual testing, because I don't have to run Memgraph. I don't have to initialize like all that just to test simple functionality. Okay, that's about testing and about project structure. So here I also add a README which explains the whole thing, but I'll cover that in more details here. So we have Rust rsmgp example. That's like just an example module. So that will be like any new module will have to be a full-blown like Rust project, and also it will have it will need to have C-string macro as dependencies, because I think it will need to have that because we have to like pass these strings as errors to Memgraph. So I don't think we'll be able to avoid this. And at this point, we just reference a local system crate. But in the future, that will be, of course, we'll publish the crate on the crates.io, and a specific version of that crate will be used in the future. And here we just create as usual. So we just create a library that has this long name at this point, but that will be shorter. That will be whatever is the name of the project, of the library. And also that's the dynamic library. So when you compile the project, the module, a dynamic library will be created, and after that you will be able to load that from Memgraph. Okay, here I just changed the namespace, the use statements. Cargo lock is not important. at this point. We also changed the name of the system crate. We removed the actual library from the system crate because the system crate doesn't create any library at this point. It just has the code. I think the system crate will only have the code, nothing on the library side. And here we optimized a bit the MG procedure because we are referenced that multiple times. I mean, twice. It's not or 3 times. It's not huge, but it's something. And yeah, here under the system crate we have the top level lib rs file, which includes mock all for the test purposes and mock double for all the code, because we have to create these two versions. So that's also required as a full-blown build dependency. And we make public these two modules, MGP and RSMGP. So MGP is a binding for the C API, and that's exposed directly at this point. So you can use bindings in an unsafe way if you really need to. But we'll see about that in the future. Maybe we won't have to expose that at all. At this point, it's just exposed because like not all functionalities are covered. And RSMGP, that's the actual library code that should be used all or most, or at least most of the times. Then we have this, and I'm actually, so when I compile, that's a bit off topic now, but when I compile, at some point my Rust compiler complained that I should put these ignore statement here, the ref null pointer, but now it compiles that it's unknown lint. Let's just Google for that. Yeah, so this is as a linter. Yeah, I'm not sure why that's unknown lint. Maybe that's because yeah, I'm not sure. I'll check for that because I don't understand why I'm getting on by default. Probably my compiler changed in the meantime, and then that's became on by default. Let me just quickly remove that, since you don't need that. I haven't seen that note. What about this? That's also. What's gonna happen if I do this? Okay. Cargo test. This should now pass. Yeah, so non-snake case. What about now? Now we don't have. Okay. Rust C version. Which version are we using? 0.5.0. Okay. Okay. I'll commit that a bit later. That's fine. And here we just again restructure a bit the use statements, but that's fine. Also that's fine. We removed the main rs. That's a cleanup, so we don't need that file anymore. And here we also don't need, yeah, we just move that elsewhere in the system crate. All right, that's it. What I wanted to show actually. Is there anything else I mentioned? I forgot. I don't think so. Okay. Any questions? No questions. Which is fine. And all right. Let me just say a couple of words about the plans. So regarding the plan for the next stream, there is a plenty of stuff to work on. So I've listed all to-dos here, and basically I think I have all the right building blocks for doing the actual code and implementing all the methods and providing all the Rust calls required. The only thing that I'm not sure about at this point, maybe I can zoom in a bit. Yeah, the only thing I'm not sure about is the allocator. So in Rust, it's also possible to define a custom allocator for the heap allocations. I mean, most of the stuff in Rust is on stack, but for the heap allocation, there is a possibility to define custom allocator, and Memgraph provides MGP memory object and also a couple of functions to allocate memory, but we have to somehow plug that in. And my biggest issue at this point is that a way how you define an allocator, you have to provide these function calls, Rust allocate, Rust deallocate. But here, instead of calling malloc, we should call mgp alloc and mgp dealloc, or destroy, how is the function called. And that's a bit problematic because these are like C function calls that have the exact signature like this one. And here we need to pass the MGP memory object, which is a bit tricky. And then idea is to use to create some kind of a context for each procedure call that will contain MGP memory, and it also can contain MGP result, because MGP result is also per procedure call. The problem with that is that we have multiple, during like runtime, we have multiple libraries, and each library has multiple procedures inside. And the problem is from one library, the same procedure, or even like the same procedure, could be called concurrently, like could be called multiple times at the same time. And if we start sharing some state, if we introduce some shared variables with MGP result and MGP memory inside, that can be easily like some race condition, or we could have like different objects, different MGP result object in the same library code, and that would be a mess. My idea at this point is to test these thread local storage keys. I put here the wrong link. Okay. That's that. So inside Memgraph, each procedure call is run inside one thread, and that's the guarantee that we have. And it's okay to store. I think it's okay to store these values in a thread local manner, in a thread local fashion. So just to store them per thread, and then reference them from these calls in C. But I have to test that. I have to be sure that I know what is going on, because that will change the code significant. I mean, it can simplify the code a lot, because we don't have to pass MGP result and MGP memory in each function call, which is great. Maybe even we can put like everything into the context. Yeah. Actually, when I think now, everything can be put into that context. All 4 arguments we have. So we have in the library code, we have arguments, graph, result, and memory. We can put all that and pass that around together. That's gonna be easier from the coding perspective, but yeah, it has some edge cases. I think I'll try to test that first, and then I'll move on with the rest. We'll see how that will go. At least I'll have some insights next time about how this went. Okay. Still no questions. I hope this was useful, and I've managed to explain these things. Next time, as I said, I try to do this, and yeah, my goal is to finish this Rust query module series as fast as possible. Now I learned a lot about these things, so it shouldn't be a big problem to finish that, but we'll see. Yeah, next Saturday, the same time. Enjoy the rest of the weekend, and yeah, see you. Bye bye.